Section 3.1, page 214, talks about defining the derivative. The tangent line to the curve y equal f of x at a point a, f of a, is the line through P with the slope of the tangent being the limit as x approaches a of f of x minus f of a over x minus a, which is the derivative evaluated at a. This is equation 3.3. In this section, they're going to use this format and this format, but later on, we're going to stick with this. You could really stick with either one, it doesn't matter. They turn out to be the same, but this is the one that's going to be defined in the next section. So we're going to focus on this more on the long run. And this says, again, the slope of the tangent is the limit as h approaches 0 of f of a plus h minus f of a over h. Let me elaborate. Of course, provided this limit exists, then that's the slope of the tangent. So, idea was, and I did this in the, I believe the second lecture or the first lecture where I went to online, but let's say you have a curve y equal f of x, and you'd like to find the slope of the tangent at a point. Let's say the point is a. So we would like to find the slope of this tangent line. Well, we know this is a f of a. Actually, I don't need that. All right. So this is what we do. We pick another point, and I'm going to pick, these are going to be a bit hard to see. Okay. Okay. So what we do, we move a distance of a. I'm sorry, we move a distance of h. And this point becomes a plus h. So when we go up to the function, we say, look, this point is a plus h, f of a plus h. And the slope of the secant is y2 minus y1 over x2 minus x1. And you notice, so this is secant line. You notice the a's cancel out. You're left with f of a plus h minus f of a all over h, which is this definition. Of course, I could derive the other definition as well. It's the same idea. But now, so this is kind of like when we were taking the limit, when we were trying to figure out what's the limit as x approaches 5. So when I said, hey, give me a number close to 5, you said something like 5.5. So I'm going from 5 to 5.5, and that means h equals 0.5. Now, what I'll do, I'll find this slope of this secant line. Yes, we are in agreement that, you know what, this red line is not the same as the blue line, but the blue line is somewhat close. And then what we do, we got closer. We said, give me another h. If we take h to be half of it, and we draw a tangent line, a secant line right there, we notice that the orange line is not the red line, but it's closer. Something like when I said, give me another value, and you said 5.1. So here he's letting h equals 0.1. And I noticed that, yes, the blue line was further apart, but now the orange is closer. And then I do it again. If I pick another point closer, and I draw the secant line, I notice now these two are very close. Something like when I said, okay, so let's go over the idea one more time. I'll start the limit. I say, hey, let's say 5. Give me a number. You say 5.5. Well, in that case, h equals 0.5. Then I say, give me a number closer to 5. You said 5.1. Now h is 0.1. Then I say, give me a number closer, and you say 5.01. If you go from 5 to 5.01, that's 0.01. And I notice as I get h to be closer and closer to my a, the line become closer and closer to the tangent. So if I wanted the slope of the tangent, and notice what h is, 0.5, 0.1, 0.01, if I take the limit as h approaches 0 of the secant line, that would be the derivative at a, or the slope of the tangent. And that's really where it comes from. I derived that already, kind of like the theory. Back, I used the website, and I went online on the previous lectures. I can't recall which one. Let me see if I could find it. I believe it's the very first one. Yeah, right there. The very first one. We went to that website and I played with it, and that's what we got. Well, here we are. Now what? Use section 3.4 to find the slope of the line. Okay, and then find an equation of a line at A. So A and B. A, I need to find the slope of the line. Now, if I want to find an equation of a line, that's simple. If x equal -1, put -1 in. You'll get -1/5 plus 6 over 1. So if you get a common denominator, 30 minus 1 is 29 over 5. All right. Well, I have a point. I need the slope. How do you find the slope? You find the slope by saying f prime at -1 is the limit as h approaches 0, f of -1 plus h minus f of -1 over h. And you notice, if you let h equal 0, you get 0 over 0. That's going to happen every time. So we need to manipulate this. And how do I get 0 minus 0? If you put an h equals 0, you get f of -1 minus f of -1, which is 0 over 0. So this will be, what's f of -1 plus h? That's -1 plus h over 5 plus 6 minus f of -1, we said was 29 over 5 divided by h. Well, this is a complex fraction. How do you simplify a complex fraction? You make sure all the terms have the same denominator. In this case, it's 5. You make sure that every term in the complex fraction will have the same LCD, and therefore you could ignore the denominators, multiply by 5 top and bottom, 5 top and bottom, and you can ignore the denominator, and this becomes a single fraction. And this becomes automatically the limit as h approaches 0 of just the top, -1 plus h plus 5 times 6 is 30 minus 29 over 5h. And that becomes the limit as h approaches 0. Let's see, -1 minus 30 plus 30 cancel out. And what happens when you cancel the h's? Isn't that just 1/5? Because the limit of a constant is the constant. So that's part A. And part B would be y minus y1 equals m into x minus x1. And there's my equation of a line. Done deal. So we run across really 4 types of problems. 5 if you want to count this linear not being a polynomial. We want to come across linear equations, polynomials, radicals, rationals, right? Trig comes up a bit later. Let's do this again on number 14. The point, if I put x into 0, I'll get a 1. So I want to find the slope of the tangent at 0. F prime at 0 is, doesn't look pretty. F prime at 0 is the limit as h approaches 0, f of 0 plus h minus f of 0 over h. So I suggest you write this as many times until you memorize it. F of 0 plus h, so that's really f of h. Pretty much wherever you see an x, plug in an h. Minus f of 0, well, f of 0 we found to be 1. There it is, limit as h approaches 0. Again, here I get 0 over 0. Here I'll get 0 over 0 all the time until I cancel that h. So that h will cancel out every time. Now I notice those two cancel out. If I factor an h out of the top, I'll get the limit as h approaches 0 of -1 minus h. Let h equal 0 and you get a -1. There's my slope of the tangent. And in part B, y minus y1 equals m into x minus x1. Of course, you could clean that up. I don't care about that. And there it is. Next problem is a radical. Well, let's see. If I put 1 in, square root of 9 is 3. Now, by the way, I did want to mention, the book says use equation 3.4, which is why I'm using 3.4. The next set of problems is going to say use 3.3. Now, I want to make sure that you know how to do both, so I'm going to work out both. And you could stick with either one of those and just proceed. So here, I have the point, I need the slope. What's the slope of the tangent at 1? That's the limit as h approaches 0, f of 1 plus h minus f of 1 divided by h. That is the limit as h approaches 0 of f of 1 plus h, put that in there, that's the square root of 1 plus h plus 8 minus f of 1, which is a 3, divided by h. That's the limit as h approaches 0 of square root of h plus 9 minus 3 over h. Now, the good news about radicals, square roots specifically, if you ever get to clean them up, you need to multiply by the conjugate. And that's pretty much all you have to do. The conjugate is exactly what you see, the same radical and the same number, basically those two identically. The only difference is you make sure that those have opposite signs. By doing that, we are guaranteed that those are conjugates, and therefore you get the first squared, and the square will cancel the radical, minus 3 squared, which is a 9. The denominator I wouldn't distribute because I already know that h is going to cancel out. No need in distributing that in, because if you do, then you're going to have to factor that out later. And that those two cancel out. I'm looking at the limit as h approaches 0 of h over h square root of h plus 9 plus 3. Those cancel out. And one more step. Lengthy problem, it's okay. That's the limit as h approaches 0 of 1 over square root of h plus 9 plus 3. If you let h equal 0, well, you'll notice that if you put a 0 there, you get square root of 9, which is 3 plus 3. So the slope of the tangent at 1 is 1 over 6. That's part A. Part B is fairly simple. Y minus y1 equals m into x minus x1. And there it is. Part B you can get in no time. The hard part is finding the slope of the tangent, which is a massive deal for us. So again, I want to touch on everything that I'm giving you, all 4 types. This is the 4th type. If I really wanted to find the point, if I take x equal 4 and I plug it in, the point will be 4. If I put a 4 right there, that will be 4 minus 1, which is 3. Negative 3 over 3 is negative 1. Now, to find the slope of the tangent at 4 specifically, we say f prime at 4 is the limit as h approaches 0, f of 4 plus h minus f of 4 divided by h. That is the limit as h approaches 0. This I already know is a negative 1, but f of 4 plus h, you put it right there, negative 3 over 4 plus h minus 1. That is the limit as h approaches 0 of negative 3 over h plus 3 plus 1 over h. Again, a complex fraction. The LCD for the top and the bottom combined would be h plus 3. If I made sure that each of those is over h plus 3, I can eliminate the complex fraction and transform it to a single fraction, which is a lot easier. Now that they both all have the same denominator, I could ignore it completely, and that would be the limit as h approaches 0. The top will be -3 plus 1 times h plus 3, and the denominator will be simply h into h plus 3. And if I clean that up, pretty much that's it. And the h's cancel out. And if I plug 0 in, I get 1 over 3. That's A. Part B, find equation of a line. My point was, I can't recall, 4, -1. So y minus y1 equal m into x minus x1. And the slope of the tangent I just found to be 1/3. And that's basically how it works. I wanted to do one more rational because that's a bit challenging. If I put 3 in, 3, I'll get 3 over 9, which is 1/3. So when I want to find f prime at 3, that's the limit as h approaches 0, f of 3 plus h minus f of 3 divided by h. That is the limit as h approaches 0. F of 3 plus h is 3 over 3 plus h squared minus f of 3, which is 1/3. And that's, again, at any time I replace h by 0, I get 0 over 0. The LCD for this problem is a bit more work. That is 3 into 3 plus h squared. So this is missing a 3. This is missing a 3 plus h squared. And this is missing a 3 into 3 plus h squared. So if I ignore the denominators completely, read the top, this is the limit as h approaches 0. 3 times 3 is a 9 minus 3 plus h squared over 3h into 3 plus h squared. Now, that is the limit as h approaches 0 of 9 minus, and if I FOIL that, 9 plus 6h plus h squared. The denominator I just copy. Limit as h approaches 0, 9 minus 9 minus 6h minus h squared. If I factor an h out, and now if I let h equal 0, I'll get, that's a 0, that's a 0. I'll get -6 over 3. 3 times 9, 27. I'll get negative divided by 3, -1/9. And my equation for the line, this is part A, of course. The equation for the line will simply be, there's the point, y minus y1 equal m into x minus x1. And there it is. Again, you're welcome to distribute that and work it out. But that's not more simplified than what I have. This is an equation of a line. I know many students were taught to use y equal mx plus b. That's not more simplified. That's the same thing. Now, as far as a derivative, you could survive by this much. You really don't need this because you could use that one definition and stick with it. But they want us to use this definition, and I want to make sure that you know how to use it. Again, it's easier for certain functions. So find just the slope of the tangent. I guess by now you know how to find the equation of a line. You notice that's not hard. The hard part is finding the slope of the tangent. And let me remind you, f prime of a, if you own is 3.3, limit as x approaches a, f of x minus f of a over x minus a. So a bit different than the previous, but there's only 2 of them. That's it. So here, if I say find f prime of 3, you'll say that's the limit as x approaches 3 of f of x minus f of 3 over x minus 3. And again, in case you're wondering, if I replace x by 3, I'll get f of 3 minus f of 3 over 3 minus 3. You get 0 over 0 every time. So the algebra is a must. Limit as x approaches 3. F of x is negative 7x plus 1 minus f of 3. If you put a 3 in there, what do you get? You get negative 21 plus 1, which is negative 20. And you'll notice this will be easier for many problems. And again, when we get to the next chapter, I'll show you how you could get around and use this all the time if you wish. That's negative 7x plus 1 plus 20. And that is negative 7x plus 21 over x minus 3. I'm still getting 0 over 0. If I factor a 7 out of the top, or a negative 7 I should say, I'll get x minus 3 over x minus 3. The limit of the constant, if you recall, is the constant. And there's my answer. So again, we're going to do the same. A linear, quadratic, radical, and a rational. So here, if I want to find f prime at 1, that's the limit as x approaches 1, f of x minus f of 1 divided by x minus 1. Again, it's right there. So when x equal 1, well, let's see. That is the limit as x approaches 1. F of x is pretty much what you see. F of 1, if I let x equal 1, I'll get 3 plus 2, that's 5 minus 1 is 4. Over x minus 1. Again, every time you use plug 1 in, you get 0 over 0. And what do you think this means? This means you're going to factor the top and the bottom. There it is. And what are you left with? The limit as x approaches 1 of 3x plus 2. And if you plug that in, you get 3 plus 1, which is a 5. And there it is. You know what? There it is. Okay. And if I deal with the radical, if I let x equal 6, 4 square root of 4 is 2. So f prime at 6 is the limit as x approaches 6, f of x minus f of 6 over x minus 6. That is the limit as x approaches 6. F of x is pretty much what you see. F of 4 is 2 over x minus 6. And we know what to do. Again, if you let x equal 6, you get 0 in the denominator. And 2 minus 2 is 0. You multiply by the conjugate. That never gets old. Actually, that's the beauty of radicals. You know exactly what to do. So if you multiply by the square root of x minus 2 plus 2, you will get the limit as x approaches 6. The denominator, the reason we never multiply those because they're going to cancel out this. That's where the 0 is. The top, I'll get the first squared minus the second squared. And what do you notice? It's magic. No, it's math, really. Isn't that x minus 6 over x minus 6 times square root of x minus 2 plus 2? So these cancel out. And last step, substitute a 6 in and you're done. Didn't like that. So if you put a 6 there, that's 4. Square root of 4 is 2 plus 2. The slope of the tangent is 1/4. Of course, if I actually find the equation of a line, it's really easy. that point is right there. And rational function, if I want to find f prime at -1, that's the limit as x approaches -1 of f of x minus f of -1 over x minus a -1. So that is the limit as x approaches -1. F of x is basically what you see. F of -1, if I put a -1, that would be -1 1 over -4, so -1/4. So it's going to be f of x, f of x, exactly what you see, minus f of -1 is -1/4 over x plus 1. That's a complex fraction, that becomes a plus over 1. LCD for the top and the bottom is 4 into x minus 3. Multiply this by 4 top and bottom. Multiply this by x minus 3 top and bottom. And multiply this by 4 into x minus 3 top and bottom. And you could ignore this denominator completely because they're all the same. And if you're not sure what that means, ask me in class and I could show you. So if I multiply those, that's a 4 plus x minus 3 over x plus 1 times 4 into x minus 3. And if I simplify the top a bit, I notice that that is x plus 1 and all what I have to do is plug in -1. I'll get 1 over 4 times -4, so -1/16 would be the actual. And I'll do one more again just for extra practice. If I want to find 4, put 4 in, you get 1 over square root of 4, which is 1/2. Well, f prime of 4 is the limit as x approaches 4, f of x minus f of 4 over x minus 4. That is the limit as x approaches 4. F of x is 1 over radical x. F of 4 is 1/2 over x minus 4. This is over 1. Again, a complex fraction. The LCD for the top and the bottom combined is 2 radical x. This is missing a 2. This is missing a radical x. And this is missing 2 radical x. That is the limit as x approaches 4. And I ignore the denominator since they all have it. That reads 2 times 1 is 2 minus radical x over 2 radical x into x minus 4. If I let x equal 4, I'm still getting 0 over 0. Since it's a radical, I know the drill. I'm going to multiply by the conjugate. Hopefully by now you're comfortable with that. And what that does, for the top of this fraction, that's going to get me the first squared. 2 squared is 4 minus the second squared. Square root of x squared is x. And if you pay attention, you'll notice those are opposites. You could cancel opposites by getting a -1. That's algebra. -1 over 2 radical x. Now if I let x equal 4, I'll get 1 over twice square root of 4, which is -1. That's a 2 times 2. That's the slope of the tangent. And that's the big secret. That's pretty much what we focus on for the majority of this course, the derivative or the slope of the tangent. Now, a couple of more problems really quick, and we're done with this. Use the following graph to evaluate the slope of the tangent when x equal -3. When x equal -3, you're right there. If you have a straight line, the slope of the tangent and the slope of the line are the same. And since this line is straight, horizontal, the slope of any horizontal line is 0. And if I look at 1.5, 1.5 is halfway. I notice the graph is not there. So f prime of 1.5 in this case does not exist because it's not in the domain of the graph. Nothing more. And I have one more. For the following exercise, use the limit definition to show that the limit does not exist. Okay, remember the shortcut for a limit that we talked about? Remember when we did limit laws right there, the shortcut? So we're going to apply that right here. Let's see. This is a radical function. If I want to find, and you could use either definition, I'm going to stick with f prime at 0 is the limit as h approaches 0, f of 0 plus h minus f of 0 over h. That is the limit as h approaches 0. F of h is h raised to the 2/3 minus, if you put 0 in, you get 0. H approaches 0. This is nothing more than h to the 2/3 over h. That is the limit as h approaches 0. And if I simplify this algebraically, that's 1 over h to the 1/3. Or, to be more specific, cube root of h. If I let h equal 0, I'll get 1 over 0. And what does that mean? It does not exist. Now, what does it mean? Why does it not exist? That's the next section. Now, that would be it. I chose these problems from our book. And that covers this section.